particular demonstration, reuse the imported sheet metal data quick look demo, I wanted to give you a how-to kind of an overview of how to perform this particular demonstration. So what I'm going to do is we have a small assembly here, and we want to talk a little bit about importing data. Now I've created an inventor part and a SolidWorks part that we pushed out as X underbar T so that we could read it into Solid Edge. And so what I'm going to do is go to our library and go ahead and grab the inventor one that I've already brought in and created a sheet metal file, Solid Edge synchronous sheet metal file from. I'm then going to go ahead and use mate and align to get this part in its proper location. Let's go ahead and set this at 1 millimeter distance and pick the back face. And then we can go ahead and add the alignments that we need. And then the final alignment will be to this top angled edge, but I want to set that at a floating option so that it'll just kind of float up there. It's not going to be at the exact same level. Then what we want to do is go ahead and get this resized. Now it came from another assembly that we have, so it's the wrong size. I want to be able to adjust it, but we can do that right here in the assembly by simply selecting the outside face and go ahead and make the adjustment. And in this case what you want to do is key in a value of 10 millimeters. And you're going to see that there's a little bit of a gap so that this thing will pivot up on those bolts without hitting the side walls. Now basically what this is a trap door for the grass to escape when out of the housing when somebody is mowing, and it's going to have a lever that's going to pull this up, this pivot up. So we still need to create this door. So what I'm going to do is go ahead and go to the open command, and in this case let's just show you how we can bring in this SolidWorks part. We'll just simply open it into a synchronous ISO sheet metal template using a template, and you can see that it brings it into the synchronous sheet metal environment. The next thing that we want to do is basically transform this into a sheet metal file, so we'll use the command to do that, and I just identify the face and everything else is taken care of. Now you'll notice that it built a tab with a bend and a flange. Okay, so at this point we still don't really know how this is going to fit, so I'm going to go ahead and save it, and we'll save it as a SolidWorks door.psm file, and it's going to put it in this same folder with the other parts. And then we can go back to the top level assembly, and you'll notice when we go there that file will appear. There it is right there. So now what we're going to do is go ahead and just drag this into our assembly file, just like we did the inventor sheet metal file. Put a mate between the two faces and then align these two thin edges. Now obviously we could add a mate or a line, but I'm just going to drag this in just to make it quick and easy. Kind of get it into the location that we're looking for. Obviously it's at the wrong angle, so we've got some changes that we need to make. In order to do that, I'm going to go ahead and let's go ahead and collapse this so you can kind of get a better idea of what we have here. And I'm going to go ahead and in-place activate into that sheet metal file. I'm going to pick the back face. I'm just going to put it up on the bend, and then I'm going to pull it out. Now I'm just going to kind of pull it out so it's coming straight down. But you notice I still have a little bit of a violation there. So what I can do to fix that is let's just place a line on our back face or front face, it doesn't really matter, and then I'm going to add a jog, and then I can just pull it out, and really it doesn't really matter what the distance is. We'll just pull it out some specific distance. Now at this point we still have a little bit of a problem here, so I'm going to go ahead and grab this top face of the sheet metal file, and let's adjust it up above where it needs to be. Also, I might want to add a tab on this top edge, so when the linkage comes down it can hook into it and pull this up off of this pivot. So just by selecting an edge, you'll notice that we get the steering wheel, or in this case it allows us to add a flange to the model. Now of course I got different options here, whether it's material inside, outside, or even bend outside, and I can just pull that up to the distance that I'm looking for. If I want to add a round, I'm going to fence it in, and it's going to take the default, I believe it was 10 millimeters, and add that round. Of course, then I can add a hole in there just as quick. So with that, let's go ahead and go back to our top level assembly, and let's take a look at what we have here. We've added these particular components. So let's make some adjustments. Another thing that I need to do is I want to lift up this particular face. So let's switch to face priority and select that top face. And I'm gonna go ahead and turn off orthogonal to base, and you'll notice I can pick that inventor part and just select that face and just drag it up. So when you get it to the adjust it to the height that you're looking for, you'll notice that it lifts the whole model up. Now if you need to make some more fine tuning or some type of adjustment, just grab a face on the sheet metal file and pull it down. And we can just close that down a little bit, and that completes what we're wanting to do with this particular assembly. So with that, you can see that we were able to bring in some foreign data, in this case an inventor and a works part. We were able to bring them into sheet metal, transform them into sheet metal files, add more flanges or bends or jogs, and then at the same time at the assembly level we can manipulate both of them in the same manner by selecting faces. So with that, it kind of completes the how-to demonstration for the reuse import.